All right, anytime you're given a table, you want to be like, yes, all the numbers I need are right there. So like it makes things easier for you, right? So use the values in the table for a midpoint sum with 3 sub intervals. All right, don't be too proud to circle them. 1, 2, 3. Those are your sub intervals, right? Are the lengths of the sub intervals uniform? Are they all the same?
Yeah.
Yes, and they're all how much? 0.5, 1/2. Okay, I like fractions, so I'm gonna put a half. And then what numbers are we gonna add up together? It said did it say midpoint? I think it said midpoint. Midpoint sum. All right, so which numbers are we gonna use? Yep, good. 6 plus 11 plus 16. Technically, because it's free response, you don't have to do anything to that. However, do you see how there's another part to this problem? We're going to use that number to do something else. So we actually do kind of need to simplify it down because we're not finished with the problem yet. So let's see, if you add those together, 16 and 11 would be 27, 33 halves. Probably. All right. Now it says if f of 0 is 7, use your approximation to estimate. And the reason it's an estimation is because this number is an estimation of the area. We can't find it truly because all we have is this table. To estimate the value of f of 1.5. So this is what we estimated. Integral from 0 to 1.5 f prime of x dx. This is your fundamental theorem of calculus. You do an antiderivative. So if this is f prime, when you do the antiderivative, you get just regular f of x such that 0 to 1.5. Good. And that is approximately 33 halves, like what we got there. And that's why I said we should simplify that down because I need to like reuse that number. And then again, your fundamental theorem of calculus says you do upper boundary minus lower boundary. So it would be f of 1.5 minus f of 0 is approximately 33 halves. And they told us what f of 0 was. What was f of 0? It's given 7. So if you add that over, your f of 1.5 is approximately 33 halves plus 7, whatever that is. And you can just stop there. You don't need to simplify that further because you're done, like finished with the problem. Okay. And I guess technically, instead of 33 halves plus 7, you could write all of this plus 7. That's technically allowable as well. Okay. But since we had to reuse that number, I was like, here, let's simplify it down. Are we okay so far?
Yeah.
Free response. All right. Let R be the region in the first quadrant bounded by this graph on the interval, that thing. Find the area of R. Integral means area. So how will we set it up? They gave you everything you need. Like they gave you all the ingredients. You kind of just need to put it together. Integral from where to where? 1 to square root, but yeah, don't overthink it. Of what? Yeah, this thing. Now, I am going to go through and divide both parts of that by the x squared. Do you see what I'm saying there? Okay, so if you take x cubed divided by x squared, there would just be x, good, plus, and then if you have 1 divided by x squared, it would be x to the negative 2. And then what goes at the end? Dx, good.
That's pretty.
Yes, and we won't get a plus c in this one, and that's actually a good conversation to have. Why will there not be a plus c? It's definite, there's boundaries, okay? The plus c is if you don't have these boundaries, okay? Antiderivative of just plain x is 1/2 x squared. All right, antiderivative for your x to the negative 2. You add 1 to it, so it becomes less negative. It would be x to the negative 1, good, and then you would need a negative in front of that. You can always check it by doing the derivative. If you do the derivative of this, you should get what you just started with. And then such that 1 to square root of 5. Now I'm going to rewrite, I'm just going to use my eraser and erase that x to the negative 1. How would you rewrite that? Yeah, 1 over x, good. And then it's upper boundary minus lower boundary. So we're going to plug in square root of 5. Now square root of 5 squared would just be 5 times a half would be 5 halves. But again, because it's free response, you can technically write 1/2 times square root of 5 squared. You don't have to simplify it down. I just don't like to write that much, right? Minus 1 over square root of 5. And then we're going to plug in 1, which would give you 1/2 minus 1. And again, you can stop there. You don't have to simplify it down. In fact, please don't, because I'll have to set aside my answer key and figure out what it actually is supposed to be. And there's no point because you have a square root of 5 in there anyway. So just leave it alone. All right, I had a typo in this one. It should be the line x equals k. It does make a difference because it's a horizontal or vertical line. The line x equals k, vertical line, is going to divide R into 2 equal areas. Can we envision that real quick? Like you have an area of something and then like a guillotine, it comes down and divides it in half. Do you get what I'm saying? Like vertical line dividing it in half, right? Set up, but do not evaluate. So all you have to do is set it up. An equation, so there will be an equal sign, involving one or more integrals, so there will be integrals, that will give you the value of k. All you really need to do is get the boundaries right, okay? It'll be integral from where to where. And you're kind of using part A in this as well.
Oh, one to start.
Well, from 1 to k, f of x dx. Oh wait, was it called f of x? Sometimes they call it r or something else. Was it f of x? Yeah, okay, be careful you call it the right thing. All right, equals, and then because it's split it in half, 2 equal boundaries. What's the boundaries on the other one? Yeah, k to square root of 5, f of x dx. And that's it. That's all you got to do. That's worth 2 points.
Oh.
It's basically getting the boundaries right on this one and the boundaries right on that one. That's all you got to do.
I like that.
Yeah, I like that one too. All right, what is the average value of f of x on this integral? Yes, if I asked you to average a list of numbers, you would add them all up and divide by what you've got. So out front, you're going to put 1 over what?
Bye-bye.
Square root of 5 minus 1. And do you have to simplify that?
No.
No. And then it's times your integral from 1 to square root of 5, which we already did. It's this thing. So actually, I did not leave nearly enough room for that. But just copy over that answer that you got in part A and just don't do a copy error. And then that's it. So it's that answer that you got before, but then we're dividing by the length of the interval. That's what makes it an average. So those are the free response dots. All right. Now these, we're going to have to work out the whole way, because remember, if it's multiple choice, you have to simplify it the whole way down. All right, so we're going to do a right Riemann sum with 4 subintervals. Are the subintervals all uniform? No, they are not all equal lengths. So you're going to have to write them all out separately. What's the length of the first one? 1. And then we want the number on the right.
Oh.
-3, good. Plus, all right, what's the length of the next one? 2. The number on the right is 2. Cool. The length of the next one is 4. Number on the right is 5. And then the last one from 10 to 13 is 3. The number on the right is 7. And you have to figure out what that is, because that's not going to be an answer choice. And to pick A, B, C, or D, you got to sort through it. So -3 plus 4 plus 20 plus 21. It actually won't be too bad. Think about it for a second. Don't shout it out. Give everyone a chance. Or were you able to do it pretty quick? It wasn't too bad. What'd you get? Did anyone else get 42? Adding that in your head? That's what I got. All right. A graph is decreasing and concave up. That would look like this. Decreasing but concave up. So we're going to state whether each of these would be over or under. So what do you think about left? If you pull from the left side, over, because you see how the left side is further up? All right, so it's higher up. So over. That means the right sum is under. And then trapezoidal comes down to concavity. If I drew in some trapezoids, they would be very slightly where? Well, they would be very slightly over, yeah. That comes down to the concavity. This one, this is, do you remember how this goes? It's gonna be integral from something to something of something dx. You just kind of have to put it all together. So what do you think?
Fine, that's forced.
What's the lower boundary? 3, good.
Oh, it's- oh, 'cause it's, 3, 5.
So 3 to where? 7. I heard you guys talking through it, so I didn't want to interrupt you. All right, of what? Like, what's the function?
I know this. 3 plus. It's like 4 over.
Well, there's gonna have to be an x, guys. Okay, it'll be x squared. Do you see how all of that is x and then it's squared? X squared dx.
Never concept.
But you guys got the boundaries, and if it's multiple choice, you'll probably be able to pick the answer. Go ahead.
7.
So it starts at 3, and the change is 4. So 3 plus 4. You're just adding them together is all that is.
Nothing to do with this.
All right, this one is actually written out as a whole big long sum in the multiple choices. You basically just need to figure out how long is each sub interval and what numbers are you gonna plug in. I'm gonna make a little table off to the side here. If you can do it in your head, that's cool, or not. Like, I'm just gonna write it out. Where does this start? 2. And then we need to figure out what we're gonna count by. So follow me on this. From 2 to 4, do you see how the boundaries are from 2 to 4? That's a length of how far? 2. We together so far? All right, it's a length of 2. If you divide 2 into 4 subintervals, 2 divided by 4 is a half. But just like on your quiz, if you want a midpoint sum, you can't count by halves, you have to count by fourths. Okay, so this would be 2.25, 2.5, 2.75, and so on and so forth. You don't actually have to write this out if you're like, man, I really don't want to do that. I just need a visual. Personally, I need to write it out, so I did. If you can do it in your head, that's really cool. And again, I'm telling you, on the test, the way that they did this one, you don't have to actually work it out. You just need to figure out which numbers to plug in. So if you look at the sub intervals, which is the number in the middle that you're gonna have to plug in? Yeah, the 2.25. So you're gonna need this one and the 2.75. Oh, I'm sorry. And the 3.25 and the 3.75. And then how long is each sub interval, the things I circled? 0.5, okay? So each sub interval is a half, that's gonna go out front. And the first one we're plugging in is 2.25, so it's just gonna look like this. Thank you. This is right at the end of this block, so you'll take your things when you go, okay? Sorry, I got distracted by someone coming in. Do you see what I did there? I just took the 2.25 and plugged it in to the function. Okay, and then the next one would be cube root of 2.75 squared minus 5. And then the next one would be cube root of 3.25 squared minus 5. And then the last one, I'm gonna stop saying it because I know that that's annoying, but that's what it'll look like. Again, once you figure out which numbers to plug in, you'll be able to pick A, B, C, or D. Like here, we wrote the whole thing out, but it's multiple choice. You'll be able to figure it out. I believe in you. All right, number 5, a graph is increasing and concave down. That would look like this. It's going up, but it's bent down. Increasing, think of a parabola. Increasing, but concave down. We're gonna list the different sums. Now we're not gonna do midpoint because you really can't tell for that one. In order from least to greatest. So which sum would be the least? The left? Which would be the greatest? The right. So like leave a big old blank. Left is the smallest, right is the biggest because the graph's increasing. If I draw in trapezoids, they would be very slightly where? Under. So trapezoid would be next, and then the true area. This is like the actual true answer These would be the underestimates and a right would be an overestimate. So like that's the order they would go in smallest to biggest.
So we have to include like.
Yeah, like the true answer, like that's the actual answer. These are I can't remember exactly how that one is on there. I just always throw that in. Yeah, it's multiple choice. You'll be able to sort it out. All right, for this function, which is piecewise, which we haven't looked at in a while, find the value of -1 to 5. Again, integral means area. Derivative means slope, integral means area. So we're gonna draw this, just like you hopefully did on your quiz for the questions like this, and then find the areas. So this would start at -3. And it has a slope of 1. However, I don't want to go too far because where does this get split at? 2. So you don't want to go beyond 2. So do your like up 1 over 1, but you don't want to go beyond 2. It's going to look like that, like a clock hand. And technically that's an open circle, but again, like that won't matter in your final answer. So don't worry about that too much. And then what would this graph look like? Just a 4. Yeah, like, well, what kind of line do we call that? Constant or horizontal line at 4. From 2 onwards, you're just gonna have that. Oh, I guess that would be a filled in circle. You're gonna have a flat line at 4. So let's color in the area. We only want the area from where to where. Yeah, good. -1 to 5. So here's -1. So we want this piece. And then all the way to 5. So we want this piece. So what shapes did we end up with? Good, trapezoid, and I don't know if it's exactly a square or if that's a rectangle. I can't tell. It might be, I don't know, I can't tell. But anyway, yeah.
It is
So-
a square.
Well, this is 4, I think it's 4 by 3 actually.
Uh,
So it'll be a rectangle. All right, but this is a trapezoid. So it'll be 1/2 times the height. Now it's on its side, so this is the height. So what's that distance?
Oh.
3, good. And then you would add the bases. So this one's 4 and this one's 1. Oh, but actually, where is that area? It's below sea level, so stick a negative out front. It's an anti-accumulation. All right, plus, and then this would be 3 by 4. You can't leave it like that though, because it's multiple choice and your answer choices won't look like that. You have to actually sort your way through it. So let's see. 4 plus 1, 5 times 3, 15. So this is -15 halves plus 12 would be 24 halves. And so what is that? 9 halves. Cool. Go ahead.
So why is it, how did you know that it was, 3?
How did I know it was what?
How did you know that it was 3 for the,
So the base here, I'm just counting 1, 2, 3.
oh, so,
Like I just looked at it, that's 1, 2, 3, and then the height was 4 because the function was at 4, so,
I just like.
no, you're fine.
Cause I kept on seeing that the.
I know,
bottom
it's
base was
because the
4.
picture's not to scale, because it's just a quick sketch, so just be careful.
Yeah, I kept on counting it as.
So hey guys, I'm gonna try and get as much done as I can before we go to lunch. All right, for number 6, so the one we just did, find the value of this. Well, it's exactly what we just did, except what?
Absolutely.
Well, what does that mean we're gonna do?
Positive.
Yeah, so it'll be a positive 15 halves plus 24 halves, which would be 39 halves. So if it's absolute value, just treat them all like they're positive, is the takeaway there.
Don't have to rewrite everything.
No, because we already did it. Yeah, and on the test, do you remember on Delta Math how they gave you the areas of the little bumps and you just kind of like, they do that too. All right, we'll finish with this one because that like ends a section here. All right, for this graph, and I've seen them do this on free response questions too. Find the value of the integral from 0 to 6. So look, the area under the graph from 0 to 6 is this area. How could you do that though?
Just find the area of the half circle and then.
A rectangle and minus it out. Good, perfect. Okay, so what would the entire rectangle be? That would be 6 times 3, which is 18. I'm gonna write it out though, just so when I take the picture of this and it's posted, you have all the work. minus out the half star. I'm so happy with how quickly you guys caught on to that. All right, how do you do, oh, good. 1/2 pi r squared, and what's the radius of that? 3. Can't leave it like that because it's multiple choice and the answer choice won't look like that. So this is 18 minus 9/2 pi. And actually, I think they leave it like that though. You can stop there. I think the answer choice looks like that.